Okay, now we are live.
Now we are live. Okay, so
Good afternoon, Pietro. Good afternoon.
hi, Francis. How are you? Okay, so well, I think I can start. Well, first of all, I'll start presenting. Well, myself, I'm Pietro Manzoni. I'm a professor at Polytechnic University of Valencia, and here you have my contact information. So the link that you see here on the bottom is where you can find all the material that we use today and on Wednesday. Okay, today it's about Docker, and on Wednesday it will be about MQTT. Okay,
And
so
I will help you with the questions if there are any from the Discord and YouTube.
oh, okay, thanks a lot. Yes, because I have to look various sites. Okay, so I think we can start. So here you have Docker. Okay, so basically what we talk today is this new tool, and you can find here some links to where you can get started with Docker. You can install it if you want. Later, I will show you that there is actually the possibility to execute Docker online. It's a very nice tool that allows you to test it without installing it. So basically, what is Docker? So Docker is, as you say here, it's an open platform for developing, shipping, and running applications. So basically, it's a way to connect developers with users. Okay. And the nice thing is that all this is kind of dynamic and can be very, very fast. Okay, so you can create a program, share it, people can test it on different platforms. And if there is an error, it can be updated kind of real time and you can execute the new version. Okay, so this is one of the great advantages, and the software can be run on laptops, computer, virtual machines, data center, cloud providers. It's used a lot in IoT to be used on, for example, Raspberry Pis. It's very easy to use it on devices like that, and you can create your own application using this tool. As you will see in the practical part, it's very easy to use it, and it allows you to create application very fast. It is also, this is kind of an aside comment, it is also considered one of the elements that allows what is called microservices. So to move from one unique monolithic, as it's called, program to various programs that talk to each other to provide an application, overall application. Actually, in the second, well, in the practical part, you will see something related to this. I will show you a demo on how to produce what is called a TIG. And basically, it's a way to collect data from sensors, store them in a database, and visualize them, all basically combining Dockers. Well, actually, better said, containers. So the typical question at this point would be, so which is the difference between Docker itself and the virtual machine? So basically, the advantage of Docker is that it's much more lightweight than a virtual machine. Okay, so in this figure, you can see that whenever you work with a virtual machine, like VirtualBox or whatever other tool you would like to use, so you have your machine, you have your host operating system, then you need an hypervisor, so like VirtualBox. And then on top of that, you have to install virtual machine that they typically take the whole operating system, the libraries, everything, so they're very heavy. So when we move to containers, which is the kind of basic idea of Docker, is that the kind of deployment is much more lightweight. So as you can see, you can have a lot of application running at the same time on basically a slight library, a slight layer of software on your machine. So it's, as it says here, a faster deployment, much less overhead, and faster. So there is another point that you might be interested in, is what is called scaling. So it's kind of embedded in Docker. the possibility to scale services, but scale services automatically. Imagine that you are deploying like a web server, or you want a device that controls your system using HTTP. So if you have a lot of requests, they all go to the same device or the same application that can be overloaded. Okay. So what Docker provides, and now I show you how, it's the possibility to automatically replicate these services, create new services, delete services, and kind of make your application able to manage, to handle the increasing load of the application. So regarding scaling, there is Docker Swarm. Again, it's very easy. I will put in later in Discord channel a link of a short tutorial I prepared about Docker Swarm. Docker Swarm is kind of no more upgraded by Docker, but it can still be used, and it's very easy to use and very useful. And then there are other alternatives are Kubernetes, which is kind of the reference tool nowadays, and kind of the substitute of Swarm. And there is a nice tutorial here that shows you how to deploy this type of tool. So this is kind of, okay, you have your service and you want it to grow, okay? So let's go on the other direction. So what if you want to use this idea of containers on embedded devices? So there are currently a couple of solutions. One is Balena. Balena is oriented more on fleet. Fleet means that you want to share, you want to distribute your application on different embedded devices. And it's a very active project, and it works in this sense. These are not actually Docker containers. These are called Linux containers, but the general idea is basically similar. And then there is another project. I think you had a talk about this tool last week, I guess, or something like that. And I watched the talk. It was very interesting. And here is, again, taking containers, not Docker, containers on ESP32 devices. So it's a very interesting project. If you haven't watched it, please go, and it's very, very interesting. But the idea is the same, okay? So let's see the Docker architecture. Okay, now it would be this slide, and the next one may look kind of complex, but then we'll see example, and I think hopefully it will be clear for you. So basically there are three elements, okay? One is the client that you use on your machine. So this is a software that you use to handle the different containers and images. Then there is your machine, your host, that has this, what I said before, this tiny layer of software that allows you to handle images and containers. So you have both things, okay? And from an image, we create containers. So you can have an image of, for example, a tool, a software, like, for example, this is Ubuntu. And from that image, you can create as many containers as you want, okay? So you have one image, many containers. And then there is the third element is what is called registry, and it's basically a repository of your images, of the images, not the containers, the images, okay? So which is the life cycle of a container? Again, just keep this image as a reference. Now you will see how you can actually understand this life cycle. So basically, this is the registry. This is your machine, okay? So what you have is to first pull images to your device, and with an image, what you can do is run it, okay? When you run an image, a container is created, okay? So you can stop the container, you can start the container, you can restart the container, you can run many containers from the same image. And this is basically the steps that you are going to use. There is actually more, okay? So this is what we will use, but you can actually push images. You can create images locally and push them to the registry so that someone else can pull them. Okay. You can use a commit to create images from a container. You can use a Docker file to build images. So this is kind of extra things that you can do with Docker. If any of you is interested, I have prepared some tutorials on how to do all these steps. And if you are interested, you can drop me an email and I'll be happy to share with you.
So can two images be in the same Docker container?
No, you create a container from an image.
Okay. So it's all one-to-one.
Yeah. It's from an image, you create a container. But from the same image, you can create many containers. Okay. What you can do is you can create your own image, taking software from different sites. So you can combine and create your big image. So that what you typically do when you create an image, you take kind of basic operating system like Ubuntu or Alpine, and then build your application inside that image. But the relation is from one image, you create one container. Okay, and now you will see. And then there is, well, this, you can save the data part, the file system, and that's basically it. So today we will, in the next minutes, we will see how to pull images, how to run images, and how to start and stop images. Okay, and so here you have. So this is basically the introduction. Okay, if there is any question, any doubts at this point, if you want me to repeat any of the concept, I think while we do the practical part, everything will be more clear.
So there was a question, two questions basically.
Yeah.
What would be the benefit of having the same image on several containers? Can you share the workload and so on?
You have one image. So for example, you can download the image of Nginx. Nginx is a very widely used HTTP server. Okay. From that image, you can create, for example, 5 containers. And
so 5 copies of different containers.
Exactly. 5 containers. So each one is each container is a word by itself. Okay. But since they are HTTP servers, they can share the same file system, so they can behave the same. So if you have a service that is highly demanded and you just have one HTTP server, this HTTP server can become overloaded. So you can create different copies, and through any of these tools like Swarm or Kubernetes, you can have your clients automatically kind of distributed to the different replicas of the containers. So this is kind of when there is a high demand on the service that you have created. There was another question?
The other one was like, can we think a container as a template and an image as for example, ISO file or any other packages?
Well, actually, the image is considered a template. So the image, basically, if you see a Docker file, you will see how it says, okay, this image is built doing these steps, okay? While a container is a running image, it's like an application running, okay?
Okay.
Yeah, but it's hard to put everything in 1 hour to talk about Docker. Yeah. So yeah, but I think while we do some example, I think that the general idea of Docker will become clear. And then again, if any of those that is listening wants to have tutorials on creating an image or using Swarm, so I have material on that and I can share it without any problem. So just drop me an email and I can send it to you. Okay, so let's, as I said, you can go to this link, which is what we do right now. I don't know if okay, so now we are here. So what you will see is that link is basically this. Okay, so here the idea is you can do it as I'm doing. Okay, so I please let me know if you can read the screen. I try to put the font size the bigger as possible. I hope that you can read. So to follow what I will do right now is you can either install the Docker on your device, and these are the instructions, or you can use this tool, which allows you to create virtual machines that are running in the cloud and that allow you to execute Docker without having to install it. Okay. But typically installing Docker is kind of very quick. Then if you click on this icon, you will get to this Dropbox, and here we'll have all the information that I will use today, Docker, and in this folder, the code that I will use, and everything that says MQTT is what I will use on Wednesday. So again, so let's see some example. Okay, so as it says here, a container is a runnable instance of an image. So the image, if you see an image, you will see that kind of gives you the instruction on how to create your container. And as I said, you can create, start, stop, or do whatever you want with this container. Okay, as it says here. So as if you remember from the previous slide, all the images are stored in what is called registry or repository or hub. Depends on, sometimes they change the name. So if you go there, you will get something like this. Okay, this is my account. So these are my images that I created. And if you go in the Explore, you will get all the images that are available. So for example, there are more than 9 million images available. And as you can see, the images are of a lot of tools that you're used to use in many other contexts. Like there is Alpine, which is Linux version. There is Python, there is Nginx, there is Ubuntu. There are, 9 million different types of Golang. So there are basically all the software that you can use here, and you can run it as a container. Okay. So you have to create an account, but it's free, and you can use it. So regarding the way we can use containers, there are basically 3 ways. So they can be either single task, so they do something and they quit. Interactively, so it kind of execute and talk with the container, or they can run in background. So like, for example, website or something like that. So the first example is the classical example is the hello world. Okay, and it's actually the kind of image that is given by Docker as the start example. So what you basically have to do is Docker container. Actually, later we will see that container is not mandatory. Run, remember the command one, and hello world.
Okay. So just a quick question, Pietro. For running the containers, which one is better? Is it Ubuntu or Alpine, or is there any recommendation?
It's up to you. We'll see later. I will use Ubuntu and I will use Alpine. The basic difference is that Ubuntu occupies almost, 500, 600 megabytes, and Alpine I don't think it gets to 100 megabytes. So if you want, so okay, you have an image, and from the image you create your container. So if you want to create 100 containers, so clearly either your machine have a lot of memory or you will have problems. So If you want to run like 3 Ubuntu-based containers, well, you can use Ubuntu without any problem. If you want to run 100 Linux-based containers, then maybe it's better to switch to Alpine. Okay, so it's basically a matter of size of use of the memory capacity of your device. Okay, so this is the first basic example. Okay, as I said, container can be avoided. So it's basically Docker run hello world. Okay, so what you see here is this is classical. Okay, so it says, okay, I don't have the image hello world colon latest. This is what comes after the column is the tag locally. So what I'm doing is do the pulling from the Docker library. Okay, so it does the pull. It checks whether the digest, the kind of hash function applied to the image is correct. And then what it says, it runs it. So, and this is basically hello world. So it prints this message and that's it. So this is a very clear example of single task. If you manage to do this example, that it means that your system is ready. So you have installed correctly Docker, and Docker is working properly, can access the registry, and can download the image. So if you do, okay, so for example, if we do Docker image ls, you see that I have, well, these images, I will use them later. I pulled them before just to save time. And here you can see the size that they occupy. And then with this command, we will see later, you will see which are the container. Okay, so as you see, this is the hello world. I executed the command hello, created a minute ago, exited. It was a single task container, and that's it. So you see, I have these images. So if, for example, I do again the Docker run hello world, as you can see, it does not say unable to find the image. It already has the image. It executed. And if we do the same, if we list the images, I only have one copy of hello world. But if I list the number of containers, I have 2 containers. I've created 2 containers. So, and I could create as many as I want. These are exited. Later, I will show you how you can restart an exited container. Okay, so this is the basic example, and this figure kind of describes you what just happened. Okay, so this is the first one. What if you want to pull another image? So it's basically the example that you see here, Docker pull Ubuntu 12.04. Okay, so what it says is, so this is Ubuntu is the name of the image, and column separated tag. So it means that you can have many different versions of the same image. So this is Ubuntu 12, but if you want the latest version, so you don't put the tag, and it takes by default the latest. So what I will get is the latest version of Ubuntu. So again, if we do Docker image ls, you will see that now I have different versions of Ubuntu. Sorry. Okay, I have the 12.04, 104 megabyte, and this other one, the latest 7.7. So yes, I remember the size is a little bigger than they are. So, but you can see the difference when we will download when we pull the Alpine, you will see that the difference is important. Okay, so I have different version. I can bring different versions. This is important because, if you remember, one of the first slides of my presentation before is this allows to the developers to talk with users. So if a user is trying, for example, the version 25 and it detects a mistake, developers can create a version 27. So and that new version will include the modification of the previous version. Okay. You can search, okay, Docker search MQTT. On Wednesday, we will work with MQTT, and what you get are all the images that have to do with MQTT, or I mean, you can search for whatever you want. Okay, let's work with interactive container. Okay, so we interact with the container. So here we have an example. So and here we will use Alpine. Docker run Alpine, and the command is echo hello from Alpine. Okay. So again, it does not have the image here. It gets the latest. Download the image. Execute the command. You see, I say echo hello from Alpine. It printed echo from Alpine. So now again, if I do Docker image ls, you see I have Alpine. So now you can see the difference. For example, now these are real values. Okay, so the latest version of Ubuntu is 77 megabytes. The latest version of Alpine is 5 megabytes. So you see, there's a lot of difference. Another example. Oops. So Docker run Alpine ls -l. Okay, so this creates a container, and what it shows me is the content of that container. Okay, so I did a run on on Alpine twice. So if I go Docker ps -a, as you will see, I have two containers based on Alpine. Okay, one that executed the command echo and one that executed the command ls -l. So, but the idea is to create container with which we can interact. Okay, so so we can see these examples. So basically, the flags, the parameter that allow you to use the interactive mode are what it says here, the I and the T. So I means interactively, and T means connected to the terminal, your local terminal. So if we do that example, Docker run -it, again, Alpine, and the command I want to execute. Sorry. Okay, now you see that the prompt changed. And actually, I'm executing a Linux system, which is Alpine. So if I do ls -l, so this is the file system of the Alpine, and I'm interacting with that container. Okay, I can do I don't know, cd bin and ls -l, and I'm working inside this device. I can do v, which is an editor. I'm basically inside that device. As I suggest on this guide, you can do IPI. If IP is the command, the if config that is typically used to control the network, and as you will see, and we will use it later, it has a loopback adapter, it has a IP6 adapter, it has an Ethernet adapter, and it has an IP address. So it's kind of complete Linux machine with its own IP address and everything. We'll see a little more in the next example. Okay, so if I do Control D, then I'm out, and then again, if I do Docker ps -a, you see there is again my shell that I used before. Okay. So this is interactive. So basically, you obtain it by adding this -it, interactive, on the terminal. Another important thing is what is called isolation, and this is basically one of the reasons that containers are used. And again, if you watch the TOEIC talk of the other day, they are talking about the importance of isolation. So what you create, your container is isolated from all the other containers that you can create. Okay, and we will see with a simple example. So imagine here, no? Imagine here we do docker run again -it alpine, and now I run this shell just. Okay. So what I'm here, what I can do is, what I want to do is create a file. So I can do it as it's indicated here with the echo hello world in a hello.txt file. Or, well, I'm old school, so I can do a v and then insert. Let's do some Spanish. Esc. So if now I do ls-l, I created inside this container a file. Okay, so I modified this container. And so graphically is basically what you see here in this figure. So I have different containers coming from different images. Again, here we only have one image, alpine. You create a different container from that image. But in this one, the content of this one is different. Okay, so we modified the content of a container. And that does not mean that we modified the content of any of the other containers. So to see that it's true, and again, learn something about the start, restart, on how to work with containers, let's do the following example. So let's clean the screen. So if we do docker ps -a, so this, oops, oh, sorry.
So just a quick question: Will we cover the Docker Compose in this lecture?
Yeah, at the end. Yeah. At the end, I will do it.
Yeah, people are interested in that also.
Okay. Yeah. So so if I do docker ps -a, so you see that there are different containers, and you see Alpine. I already created 4 containers. So the one that where I created the image is this one. Remember, I used this version of the bash, which is ash. So now what I can do is, but now is exited. Okay. So what I can do is docker. I can start it, and I have to use its container ID. Okay. Clearly, the number on the document are related to when I prepare those materials. So the number clearly changed. Okay. So I have to look for this Alpine, this container, look for the container ID, and then docker start. Okay. So now if we look again, you see now that container is up. So it's connected, it's active, it's running. So how we can go inside it? So we can do docker. One way is to do docker attach, and we put again the container ID. Okay, so now we are inside, and now if we do ls-l, so you see there is the file that we created before. So now if we exit, and if, for example, we enter into this other one, okay, so docker start this other container. Okay, now if we, now the one is exited because we did a Control D, and this is up. The other way to enter inside that that container is the one that you see here, docker exec on that on the kind of that container ID, the command ls-l. Okay. So this basically what I do is I just want to execute this command on that container, which is up and running. Okay, and what I did is, okay, let's see if that file is here. And as you can see from the ls-l, is not there. So all the content is kept inside each container, each specific container. And at the same time, we saw how to stop. You basically stop by exiting, doing an exit from inside an interactive container, and then you can start it or you can stop it using the container ID. And you can attach to a running container, or you can exec something on a running container. Here, what it says handling containers is basically to summarize what we just saw. Okay, if we do Docker PS basically just shows the containers that are running. If I want to see all containers, I have to do -A, and here it says all the containers that are there and their status. So you see this name, these are ecstatic, Corana, pedantic, so those are names that you can use to refer to containers and are generated randomly. You can assign names and we'll see it later. So the basic rule is if you don't see your container here in the Docker PS-A, then you have to run it. Okay, you have to execute it. If appears in -A but not in Docker PS, then you have to start it as we did before. And if the container is already running, then you can do an exec, okay, by doing interactively or like we did here, non-interactively, because we simply wanted to execute this command. Okay, so the touch containers is a way to, and we will use it right now. So if you want, you can do the example. Basically means run in the background, but at the same time, you can want to interact with these containers and connect it to your terminal. So basically use -dit or -d, it depends. -name is used to name a container, and then the rest is the same. And this is, again, what it says finally is kind of summarizing the commands to stop a container, to remove a container, and some quick ways to work with containers. When you install the Docker, you obtain a dashboard like this. Okay, so this is more graphical way to represent the information. So you can see here the containers, you can see the images, and you can delete and run with it. This is an alternative to the CLI interface. Okay. Okay, so well, this is kind of in a few words how to play with, how to work with Docker. So now let's see an example that is IoT oriented. Okay. And the example is related to the TIG stack. So TIG stack is gets its name from the components that you can use to run your system. And basically, the T stands for Telegraph, the I stands for InfluxDB, and the G stands for Grafana. So basically, the idea is that you use Telegraph to collect data from a lot of different sources. Here you will see it is used to get the data from a LoRaWAN network server using MQTT, the details of MQTT on Wednesday. Those data are stored in InfluxDB, and from InfluxDB, Grafana will take the data and visualize it. Okay. So we will combine different services to obtain a unique final service. Okay. So this is basically what I just told you. And what we will use is 3 images, which are the one that you see here: Telegraph, InfluxDB, Grafana/Grafana, which is the official name of this image. So what I will do is I will do it manually, and then I will do it automatically. Okay. So hopefully that will be fast. So again, so first of all, I have to start with the center, which is InfluxDB, which is the database. Okay. So what I have to do is say docker run -b. I want to run it detached, and then here there is a new parameter, -p. -p is used to map ports from the container to your host machine. So what you want to do is have your container port to be mapped with your host machine port. So what I'm doing here is saying, okay, my host port 8086, I want to be mapped with the 8086 ports of the container. I want to name the container InfluxDB, which it will run InfluxDB, and I want to use InfluxDB 80. Oh, sorry, I'm not. Okay. This was quick because typically it takes maybe 30 seconds. I already downloaded, pulled it before. So now what we have to do is to enter into the Docker and configure the database. So, and the way we do it is, as I said before, as in the section that I showed you before. So it's already running. Okay, so if you Docker PS, we see that it's running. So we can enter by doing Docker exec. I want to interact with it, so -it. Now I can put the name InfluxDB, and I want to run Influx, which is the name of the program. Okay, so I'm inside. So what I have to do is, first of all, create the database and call it Telegraph. Okay, and now I can show databases. Okay, so you see there is one is called internal, one is called Telegraph. Telegraph is the one I just created. The internal is kind of used by the InfluxDB to handle all the data. I have to create a user, and I call it Telegraph, and I assign a password, which is, well, for a bot. I don't know if you know these cartoons, but anyway, so just password. Okay. And then what I have to do is grant all permission, grant all on the database Telegraph to the user Telegraph. Okay. And now if I do show users, you see there is user Telegraph, and it is not an administrator. So now the other step is to create what is called retention policy. So these are time series databases, so it means that it stores the data as it evolves in time. So we have to say how long we want to keep the data. Okay. So for example, here you say 30 days. Okay, so it's create retention policy, call it 30 days on Telegraph, duration 30 days, 30D, and then a couple more parameters. Replication 1, we don't want InfluxDB to create various replicas of the same database, and we want this to be the default retention policy. Okay. So now if we show the retention policies on Telegraph. Okay, so you see there is autogen is the one that is generated by the system. Now is false, and now true is the one that we just created. Well, it was 30 days, but I mean, the name is the same. Okay, so we configured the InfluxDB, we created the database, we created a user, and we set the various parameters. So now we can exit. Okay, so this is the I. So now let's go with the T. Okay, so as I said, Telegraph is the one that reads from, in this case, an MQTT broker. So if you go in the folder that I share with you, and you go to the folder Docker configuring Telegraph, so Docker configuring Telegraph, you have that same file that you see here. So what it basically says is the agent must have this kind of parameters. The flush, the interval with which sends the data is 15 seconds. And then we have an input and an output. So the input is MQTT consumer, so it reads using MQTT, and it outputs to InfluxDB.
Quick question, Pietro.
Yeah.
Is there any preferences over ELK than for TIG stack?
Sorry?
So there is another stack called ELK, Elasticsearch, Logstash, and Kibana, compared to TIG stack. So which one is?
Well, this is more used in kind of IoT. It's kind of classy because especially Grafana and InfluxDB are quite widely used. So this is kind of a tool. But I mean, this is an example of one possible combination. So it's quite efficient. I haven't seen any comparison of the two. But this Telegraph, for example, is really fast in handling the flow of data. So yes, I guess they are more or less equivalent. In IoTs, typically use this type of approach.
So probably for simplicity.
Sorry?
So probably for the simplicity.
Yes. It's very easy because at the end, you want to get data from many different sensors. So you don't want to deal with many tiny details. It depends on the application also and the type of sensor. So it's always, it says it depends. No? Yeah. But this is a kind of widely used approach for this type of application.
But what about other databases? Like if I want to use MariaDB, then InfluxDB, is it?
Well, again, InfluxDB is extremely fast. InfluxDB is extremely fast, and it allows you to handle data series. So it has embedded the fact that data is structured in time series, in sequences of data that are different just by the date, by the timestamp. But you can use, yes, MariaDB. I mean, there are various type of databases that you can use. InfluxDB, I think, is one of the most widely used because it's highly efficient. So if your application grows, InfluxDB can handle the growth in the input flow of data. So I think it's for the moment is the best option. Okay, so these are the parameters from the inputs. So we call it TTN, and this is where is my server. And these are parameters that I will explain tomorrow on Wednesday about MQTT. Again, topics is related to MQTT. Stay with me, and on Wednesday we'll understand these parameters. So, but basically these are parameters required by MQTT broker to get the data. So you need the username, the password, data format, and then what you see is the output. So it gets from that network server and it pushes the data on the database, which is Telegraph, the one we created, and which is available on this port and with this username and this password. Okay, so what we have to do is execute Telegraph. So it's again Docker run as always, the cast. So what we need now. So we need to using -v to map this file, which is telegraph.conf, inside the container that we run Telegraph. So we have kind of link somehow the file space of my host machine to the file space of the container. So the way it's done is -v. So what I'm saying is that, okay, $present working directory, the file telegraph.conf, which is the one that you have it here. And I map it with where Telegraph expects to find that file. So it's in the directory etc telegraph telegraph.conf. Oops. Okay. I want to link in read-only mode. Okay. And then there is this net, which means I want to use the same network as the InfluxDB container. So the telegraph will share the same network as the InfluxDB. So container InfluxDB and telegraph. Let's see if everything's fine. So looks that everything is fine. Okay, so here it's playing the minus minus net. Okay, so now it should work. We could go here and see. Actually, you can see if what you're running is running correctly. See, running. See, this is telegraph, and it says basically the result of the execution. Okay, so and this is it is running. Okay, so now in theory, telegraph is sending data to InfluxDB. So let's see if everything is working correctly. Okay, so again, docker exec -it, we go enter into InfluxDB, influx. Okay, I'm again inside InfluxDB, use telegraph, and now I can say select start from yeah. Okay. So let me maximize this screen. So this is basically the information that is getting using MQTT from this network server. Actually, in the slide that you see, in the document that you have is better organized in column. So here there are a lot of columns with a lot of data. But if you take a look here, this is a first element. This is basically the timestamps, the device. This is the topic about the data, and these are the values that we are getting from that device, from that server. So you see here, time, host, topic, and this is a long list of all the fields that you get from that device. You see that we are reading information. So I didn't say, but we are reading the value from sensors that I have in a lab and that are continuously producing data just for a demo. Okay. So it looks like that Telegraph is taking data, is bringing data from the network server to the InfluxDB. You see here in the document, it's more printed in a better way. You can see here, and you can actually scroll and see the details. Okay. So we exit, and now we visualize the data with Grafana. So now we need an information. Let's clean here. So we do network docker network inspect bridge. So Docker creates virtual networks. Okay. And the basic type of network is what is called bridge. And you can see there is what is called bridge, which is based on bridge. Bridge is like the classical networking bridge or switch that you may have used. It assigns some IP addresses. Okay, for example, in the area of 172.17/16, the gateway has this address. And if you see in the segment containers, you see there is one which is called InfluxDB, which has this MAC address, which is assigned randomly, and it has this IP address. Okay, so in this case, we are looking for the IP address of the InfluxDB. So there is what I left from before is another image running. So if what we are looking for, what I need is this address. Okay, in the example now it says 02. So what I have to do is docker run, again detached, name equals to Grafana. Here I need to map port 3000 with port 3000, and image is Grafana/Grafana. Okay, so now it should work. And now if you go to this link, so it's your localhost port 3000, you will get hopefully something like this. And let me share picture. Okay, so here we are in this Grafana is running inside your machine. Okay, so it's running in a container in your machine. So, well, you enter whenever you create a new Grafana instance, the username and the password is admin/admin. Okay. Typically here it asks you to create a new password. For the moment, we can skip. And then what you get is to this section where you can create these. You can configure your system. So the first step is to create a data source. So you need to provide data clearly to Grafana. So we go to data sources, we say InfluxDB. Okay. Now you can name it. Well, let's leave it InfluxDB. Okay. Now here you have to put the address, which is HTTP. This one is executed inside Docker. So you have to give the address of the machine, of the InfluxDB. So it's 172.17.0.3. Remember that we saw, in this case, it was at that address. And the port is 8086. Okay. So now what you have to do is say which database, for example, Telegraph, user, Telegraph, the password, and HTTP method get. Okay. So these are basically the steps that you have to follow. Okay. Okay. When you are done, you say save and test, and it says data source is working. So the next step is to work with dashboards and create new dashboard. We add new panel, and what when we are here, what you can create is a rule that reads from the database and writes and show the data on the screen. So, for example, we give 30 days TTN. For example, mean. Grafana has millions of options. Okay, you can, for example, here you can remove and you can do different aggregation like count, distinct. You can do transformation. I mean, you can do many things, a lot of things. Okay, so well, I typically use mean to visualize the data. And then here you can, again, do line interpolation, you can modify, you can use bars, you can just use points. Again, it has a lot of options. You can use time series, you can do bar chart, you can have something like this. So, I mean, it has plenty of possibility. Okay. So basically, we are done. So we created in basically 15-20 minutes by combining three different containers without installing anything. We created a system that is running, that is reading data using MQTT and storing in the database and visualizing, and you have your system up and running. Okay, so but what if, okay, we don't want to spend this 20 minutes every time to configure everything. So this is the last part, which is orchestrating execution using Compose. So basically the idea is, okay, I don't want to do all the steps that you have done. I want to do it quick. Okay, so let's reset everything. Let's stop everything. All the running containers. Okay. And we can leave the images there. Well, the word is in use. Okay. So here is, well, let's delete everything. Let's make a clean start just to be sure. So what we do is, let's create, what we need to do is, and you can see it in the folder Docker orchestrating using Compose. We need to create this file, which is Docker Compose YAML. Okay, and you can see it here in this part. So as you can see is basically what we did previously, organized in a unique file. Okay, so YAML is kind of markdown language. So what you have to start is with a version. You can create your own network, and what you create is services. And the structure, as you see, is you have to say, okay, I want to create a service InfluxDB, which is the equivalent to name, and which image you want to use. Okay, the name that you assign. Do you need to do some port assignment? You put it here. You need to set some environment, what I did manually. Which network want to use, the TIG network. And do you want to map data? So for example, here I have data that I used before. Okay, it's from a previous experiment. Grafana the same. Okay, you see the different. You see for to enter is admin, the same network. Restart always. And here you can see there are. This is the Telegraph. As you can see, you can also define dependencies. Okay, so saying that a Telegraph depends on InfluxDB. Clearly, if InfluxDB is not running, Telegraph will not run because there will not be the where to store the data. Here it has to say where to find the configuration file. I mean, basically what we did before, compressed in one file. We slightly have to modify Telegraph, and basically here is the difference, because here now everything will be run inside the container, so it's simply a matter of setting this value. And starting is very easy because it's Docker Compose up. So what it will do is, that was too fast anyway. So basically what it did, since it's already at the images, you say it's start running the different element, the different containers. Okay, so and here basically, let me put it in a little bigger. So it's basically messages coming from Grafana, for example, or from InfluxDB that are basically saying that how the system is working. And then again, if we go to this address, we get again Grafana. Again, we enter admin, and then we have to start as before configuring the last. And we have to create our dashboard like we did in the previous example. So this and the rest is all default. So this basically is the way to proceed when you have clear how your containers have to be combined and how they interact, all the proper parameter. You can create this file, so you can say up to activate it, down. I mean, there are a set of commands that you can perform on with this type of. Okay, so this is basically it from my side. Again, Docker is kind of complex word, so putting everything in 1 hour is kind of complicated. If you have interest in any of the details, for example, creating an image using Swarm or other details, you can write me an email. For example, on Wednesday, we will use how to create an MQTT broker using Docker in 10 seconds. So it's basically, again, with the Docker Compose, and you will see that it's extremely easy. And it allows you to always run the last image created for that specific service. So, I don't know if there is any question.
Not related to the Docker Compose, but there was a question about your in the tutorial document. You showed the structured table with a good representation of the data, right? So in that table, is it?
Yeah, the table. Yeah, the problem is that the data that comes from TTN from the network server is, I don't know, 50 or something like that columns. So when you do
the topics, or I mean,
sorry?
that was the question. So those columns, do they represent topics? That was the question.
They represent the fields that comes from the network server. So if you want, I can show you again in the document. They are shown. They are better shown. So, for example, sorry, I don't know if I'm there again.
Yeah, this one.
Okay, here I am. So you can see it's basically this column. Okay, so the time, counter, the code of the host, some metadata, various metadata, and each of that line is inserted in the InfluxDB database. Okay, and here we have all the metadata that you get from that device. Okay, so and the important thing is that each one has a first column, which is the time at which that data was inserted in the database, so that you can have the historical representation of the values, historical evolution of the values.
Yeah, I think I got the answer.
Okay. So yeah. Yeah, no, they are not. So I see now the question exactly. Yeah, they are not exactly MQTT topics. So MQTT topics are used to retrieve the data, but the data is actually a long JSON file, and which is structured in many columns, and those columns are stored as a classical line inside the database.
Yeah, so that was the question. Yeah, I think there is no more questions, so as you can see it.
Yeah. And I see someone likes YAML.
Oh, yeah, the people likes YAML.
And so I think, I don't know if there is question. Okay. So I don't know if there is any more question, or again, you can send me an email and I can clarify any of the things that is not clear. Or if you want, again, this information I have about Swarm and the other parts, I can send it to you.
Mhm. Yeah, I think we don't have any more questions. And thank you, Pietro.
Okay, so thank you. See
Interesting.
you on Wednesday with MQTT.
And see you on Wednesday. Yes.
Okay, bye-bye.
Yeah, thank you. Bye-bye. Have a nice day.